the geezer's back. It's exam season again for Unit 3 product design for your foundation diplomas. I'm just running through the research task on an old exam paper, how I approach this, what you should look for, what you should be answering. Just remember, it's a discussion that you're having yourself on this. I won't go in great detail, the details in the rest of the video. What I can say is, if you've got any questions, ask me in the comments. I will answer. Okay, if there's 300 or 400, it's going to take a bit of time, but I don't get that many anyway, so I will answer those as we go along. Yeah, if you want, just to subscribe, that helps me out. I've got another 5 videos coming out after this one, each of the 5 tasks of the exam from a past one, so you understand what you need to do for each section. It's nothing worse that you've not had a chance to see it. You'll be familiar with the format of the paperwork, what's expected of you, and we go from there. I'll shut my mouth. Let's get on with the video. So let's get down to the nitty gritty. Okay, so this is what the front page of your research task does. I will suggest that you read every single page as you go through. You've got to hand in your research paper so it can be printed off and it's there ready for you. Now, please be warned, if you go to 3 or 4 pages, it'll only be the first 2 pages that we've printed. Okay, so just remember that it's got to fit on 2 pages. That's 1 piece of paper, both sides printed. So where do we start? Well, this is the front page. This is an old exam back to May 2024. There's the second page, it's made a little bit wider there. Instructions for teachers and tutors, ignore that one. It's got nothing to do with you. This is instructions for your learners. That's for you learners, as I said there. Read the task information carefully. This contains part A, which is the information you need to prepare for the set task. Okay, you've all got eyes, read it carefully. You'll be given a set task to complete under supervised conditions. For part A, you must work independently, and you must not share your work with other learners. So, as I say, in 3 hours, it's done from start to finish, bosh. Whatever you hand in is what I print off for you. I say, your teacher tutor will give guidance on when the preparation should be completed. So mine's easy. We start at 9 o'clock, 15-minute break in the middle, and we finish at 12:15. That's how I do it at our college. And the tutor cannot give you feedback during the preparation. Please don't ask him. Please sir, please miss. What does it? Do you think this is enough? No, this comes down to you being mature enough. Hopefully, you've done enough. We cannot comment on anything that you produce. It is you hand it in, reprint it off. When you come to do your exam, that paper's waiting for you. Right, let's move on to this bit here. So page 4 and 5. So this gives you the bullet points you need to worry about, a little bit of what's happening in part B, blah, blah, blah. And the information. Please read the information first before you do anything else. So let's have a look at this. Let's go deeper into this. So the redesign for work platform. The work platform consists of a folded top plate, 2 side plates, 2 internal threaded tubes, and 2 wheel assemblies. Nuts and bolts are used to attach the 2 side plates to the outside of the folded top plate and the 2 wheeled assemblies to the outside of the side plates. The internal threaded tubes are attached to the side plates using bolts. Let's have a look at that. So there's the top plate. It says there, folded top plate, 3mm thick, welded in the corners. So that's welded there. You've got the 2 side plates which are bolted to the left and right side of the welded top plate, held on by these 2 bolts. Okay, there's a nut and bolt in there. Hopefully they've used a nylock nut, so anti-vibration. We talked about the two tubes. There's one of them. There's the second one there. Okay, 10mm internally threaded tube, and then you've got your wheel assemblies on the side there, and you've got this wheel chock there. What's it saying about the wheel chock? The wheels and wheel chocks are made from nylon. All other parts of the work platform are made from low carbon mild steel and that have been painted. The work platform is to be manufactured in batches of 1,000. All DIMs are in millimeters. Overall dimensions of the work platform, 750 length, so that's from this point here to this point here. 506 wide is from this width to that width there. So basically that top plate is 500mm. And this plate is 3mm, the back plate's 3mm, and that's where they got the 6mm, 506. And the height from the bottom of the side plate to the top of the platform is 500mm high. That's not included in the wheel assembly. Okay, so this is a side view of the wheel assembly. So you've got this U-shaped channel, you can see here, U-shaped channel, which has a screw, a nut and bolt, I think it is, end view of the assembly. It looks like it's nut and bolt that goes through there, and that nylon wheel basically gets held suspended on that rod, so it allows that to move backwards and forwards. Okay, and the wheel chocks there ×4, so you're going to be putting a wheel chock front and back to stop it rolling. Personally, I think this is the worst thing, but they're meant to design it to give you some food for thought. Okay, so please remember, you're not after a solution at this time. Think about the solutions, think about the problems that you can imagine or think that could go on with this. Okay, so nylon wheels do not grip concrete. That's going to slip and slide, so I wouldn't want to be on that. Those silly little arse chocks, 4 of them front and back, are you going to put it in position and put these little things underneath, and you've got to catch your fingers and stuff like that? 3mm thick plate, to be honest, you don't really need to use 3mm thick plate. I would have gone to about 1.2 1.6mm thickness, and folded it into use some flanges and stuff like that to give it some strength. Okay, it's at 1/2 metre high. It's too big a step. There's no guardrails around the top of it. The surface that I see is going to be slippery because it's painted as well. So you just need a little bit of water, a little bit of grease, and there off you come. You're going to be skating like Torval and Dean on top of there, and then obviously I need to be looking down at my feet so I don't step off this by accident. That's my opinion. Just remember, this batch is of 1,000. You're not going to be cutting these off by hand. You will be using some sort of automated CNC process. I mean, probably laser cutting, because it leaves a nice clean edge. Right, what do they want us to do? Existing designs for work platforms. So I'm just going to go open up the internet. Work platforms. Okay, we've got some images. We're on the Googles and that business, and let's have a look what we got. Okay, this particular one that you see on the right hand side here, this is what they use on the for construction. It's a simple platform. It's practically the same size as what we want, really. 50 by 50. These 2 folding edges there. There are no wheels whatsoever like that, so that would do the job. But I say this is a hinge part, so you can fold it away. Let's have a look at another one. Okay, I prefer to use this one because it has a checker plate at the top there. You can see there, it's a folded design, similar shape. It's got a couple of steps. You look at this one here, you see on the right hand side of the page, it has a checker plate again. It has a frame, similar size, got cross braces on there to stop it wibbly wobbly. You've got some guide rails that you see here, and it has a bar at the back to stop you stepping back off it. This is perfect for the job. This one here, okay, it has a grid on there, so this would be used for probably let's put it this way, you're milking cows in a cow shed, and when they're getting milked, they're standing on these grates like this. The urine and feces has to go somewhere, so at least it hits this, goes through, you can wash it out and that business. So this is where constantly getting flooded by liquids of any type, including excrement and all that business. I have to be careful while I work on this. My students might hear me say the S word, but hey, that's the way it goes. Yeah, so this is that, and you've got adjustable legs like this. You look at this one. This might be familiar to yourself. It's a lot higher than what we want. It's got 1, 2, 3, 4, 5, 4 steps to get to the top platform. 2 wheels on the back. They are fixed solid, and you have this wheel mechanism at the front end there. So if you beat your B&Q and Wicks, they use the old red ladders and stuff like that. They use this lever to put the front up on its wheels, and then they can actually move it around the shop or whatever it is like this. So this is maneuverable. You can see this is what they use in construction. So that's 2 that we put together. If you look at this is a hydraulic work platform. It's quite expensive to do this as such. If you look at this type here, like that. Now just take a look at how it's constructed. This is tubular frame to stop people coming off it. Is folded construction underneath, so that'd be good for portability, going from one site to another. Now When you start seeing them like this, it's got the wheels in, you see there. This is a semi-permanent fixture because you've got these jack legs here. So this would be going around vats and so on like that, where you need it. That's basically you're topping up hoppers. It might be liquids that you're using, or you're just looking at inside a process of things happening there. Another one here. This is another type of platform. Okay, similar shape. It's got the handrails around the side there. It's got steps to get up. Yeah, it's obviously a little bit higher, and it looks like this has casters which are on springs. So when you tread on this, what happens is it compresses the spring, and these black knobs there will actually will rest on the floor and stop it moving about. So when you want to get up and move it, and away we go, the springs will lift the platform up, and away you go. You can move it around. Isn't that nice? Okay. So what else have we got here? You can use another one like this. It's a bit overkill for what it is. Now, just remember what they are, what they said. Just looking at that, the work platform used by engineers to stand on, completing maintenance tasks on electrical switchgear. The switchgear is housed inside a wall-mounted control panel. Okay, so obviously wall-mounted control panel at 0.5 meter. Obviously these ain't going to be that tall anyway, so I'm only hazarding a guess that these were just above head height, so you can walk underneath or whatever it is. Okay, what else we got? What else can we see here? These are work platforms. Now, can you see this board around the outside? Now, there'll be a specific height from there to the platform that you want to work on. You've got this board around the outside. You've got these tubes in the middle. Okay, there'll be a certain height that you're allowed to, that you should have a minimum of. If you're hitting that, there'll be another bar in between, and it means that you have to crawl into that space to get on there. And these, let's say these toe boards or vertical uprights, if you want to call them that, will help you feel for the edge of the platform. Okay, it's important that you feel for that. And now, when you're looking at this sort of thing, this is a permanent fixture. There may be a conveyor system going underneath here. This allows the worker or the employee to walk up this side over the let's say the conveyor system, and then back down the other side. It's just access from one side to another. Okay, this is a permanent fixture. You have other ones like this. It's a permanent fixture. Another one like B&Q. Okay, this is fully welded assembly, and then you've got some pivots here for those wheels to jack it up to go from there. Again, it's you've got these side panels. This side panel gives you access. We've got another permanent solution. Okay, again, access up the middle. So you've got this left right steps. Okay, left foot on the left, right foot on the right. Yeah, it's quite a natty design as such. And then you access to whatever you need over here. Again, that's got a slippery surface on there. I'll be putting some grip tape on there. Another type of platform. You can clearly see the welds that are here. You can clearly see there's some bolts here. Anti-slip treads, as you see here. Anti-slip platforms. That allows you to go up and down, easy money. We could be going on at this all day long, but you have 3 hours. I would be taking images of this tubular frame that you see there. I'll be taking images of this. This is a aluminium construction. You've got some cross braces here to stop it wobbling from side to side. A hinge mechanism for the legs to fold underneath. We have this type here for maneuverability. It's a bigger version of what we want. Okay, we've got wheels at the back, and the wheels at the front will be disengaged. It looks like there's swivel wheels as well. When you want to move this, you just pull the lever. As you pull that, it levers these wheels in, which allows you to maneuver the platform. As you see there, you say there's loads of these little folding ones as such. There's one that'll probably do the job, but let's say we look at this permanent fixture here. Again, it's another permanent fixture that you see on this right hand side. As I say, it could be something happening underneath where you have to get over the line. This is one of the folded platforms with guardrails. Okay, another one that you'll see at Wickes, but this is using chains this time. Again, you've got these platform that you see there. Another one. This is just a platform that you lift up. You've got the wheels there, so you have to lift it up at the end. And as we go through here, that's a beautiful thing. Similar, it's got similar shape and size to what we want. Yeah, I think it's a little bit higher. This has got the sprung-loaded wheels here. There's another one here. You got wheels at the back. You have to lift them. You have to lift this side up to engage the wheels on the floor, and away you go. It's a similar size. It has a wet top, and looks like it's got a checker plate on the top. What more can I say? Save yourself some images. Zoom in. Crop some of the corners of the bits so you can actually see the construction. Gives you an idea. Sometimes you're going to the exam, you go, oh bloody hell, I don't know what to do here. If you've got images of it, that should give you food for thought to develop your own solution for the job in hand. Okay, beautiful stuff. Point number 2: the manufacturing process and technologies that are being used and possible alternatives. Okay, think about this. If it's sheet metal, it's fabrication. Would you agree? Yes or no? Think about it. Yes. There's a lot of them. There's 1,000 to be made. Would you cut them by hand? No. Technologies, let's look at this. What have we got available that we have here? Well, I don't really want to cut the parts out by hand. So I'd be looking at laser cutting to cut my profiles. So let's get back to the old Googles. Sheet metal lasers. Beautiful stuff. This we're here, as you see in this image here, this is a laser cut job. If you look at this type, that's a laser cut. Now laser cut is really fast on there. Nice clean edges. You see, if you look at that, nice clean edges, hardly any dross underneath, and so on like that. And I think the biggest sheet they can put on, one of my old students, is either a 3 or 4 meter wide sheet by 6 to 8 meters long, and you can get many parts. The software that you have, you use a DXF file of the profile they want to use. Okay, so when you use your Inventor, SolidWorks, Fusion, whatever CAD package you have, you can then save that image, send that file as a DXF to your laser cutter, and they will use their software to lay as many parts as they can on that sheet of metal. That's called nesting, and they cut as many as they can out of those parts. Okay, if you want 1,000 of those pieces, the software will show you how many parts can be laid on the sheet metal. Now, if you look at plasma cutter, the edge is not as clean as the laser. It's not as clean. If you look at this one here, this is a plasma cutter. You see the scorch marks on that business. You don't really get any of that on the laser cutter. This is your oxyacetylene cut. It's basically built for thick plates. Your laser will get you up to 20-25 mil. The plasma can get you, I'm not sure how thick there. Can they get up to 100 mil? Maybe a little bit more. Looking at this part here, that's the finish that you get with the acetylene cutter. Okay, that is a full laser cut part, not being dressed off, nice and clean. Sheet metal. Let's try and get that focus a little bit better. Nice and thin, as you got there. And you know what I said about nesting? That is a sheet metal. That's how many parts they got out of that sheet metal. They are. If you've got hundreds and hundreds of parts to make, you can nest them on the same sheet. So if I go laser cut part, nesting, and there you are. There's a typical one. It will lay out as many parts as it can on your sheet, and then cut what you need on it. And you can see, interlay them. That's what the software does for you. And if you look at that one there, beautiful. Isn't that nice? We can go on forever there. So here's another one. That's that. And there's the old boy picking them out as well. Perfect. So this obviously be CNC led. So if you're only going to use a part of the sheet, it will save the rest for another job. Technologies, okay, being used in possible alternatives. Let's have a look at the bending. CNC brake press. Have it. Let's go for a video. You see this. This is a form. There's a stop. You push up to the stop. Press the foot pedal. There it goes. There it bends up. It bends it both up like this. The stop will move. Can you see the two stops moving? Let's make that full screen. Have it. There you are. Bends it up so the form is big enough to do the job. Nice clean bends. Got a laser cutter on the side here. That you see on the left hand side. Puts them in. These two stops. Perfect for the job. Put it in. These are sometimes magnetic. They've got this film on it to stop it scratching the material. There you go. Perfect fold. And if you wanted to, you can weld those corners up that you see there. So you program the cut, sets the stop up. It does each bend as you go through. So obviously the stop comes forward. bends it. So you obviously you can't grip hold of this because it just flips it up. There's the first bend you can see here. Going to flip it round to the second side. So this little form should be just wide enough to get that thing in it. And see the stop at the back there? That will move ready for the next bend. Okay, they all come in different shapes and sizes. Allow you to get access to everything. What's he going to do now? There we are. Going to put that in there. That should just fit in between the two flanges there. Look at that, perfect. Bosh. Okay, and then up to the stop. It's important you put it up to the stop. There it goes. And there you go. Easy. That's a brake press. Let's go for powder coat. Obviously, there's also some preparation. This is for a single alloy wheel. Okay, so obviously it might have been curbed. They're spraying the powder onto the workpiece, as you see there. It'll be evenly coated. Now that back wall, as you see there, has got water running down it. Any overspray will be sucked into that wall, so you're not breathing those in. So you need to think about the health and safety as well. It's not specifically spraying the wheel in a set pattern. Just make sure you've got full coverage. It goes into an oven, and then this is a lacquer to go over the wheel, and it goes in that oven. Right, so we've cut the plates, we've bent the plates where needed, and think about a powder coat. It needs to be painted, so you can either wet spray or you can powder coat. If it is a batch of 1,000, you're not going to set up a production line for this. Not practical. 1,000 off, you may want to utilise a robot arm. So they're quite quick to teach. So jigs and fixtures would be essential here. Or you might be a nut and bolt assembly. Now again, you will not use robots to put this together. This is going to be a manual job. If you can build it as fast as you can using appropriate nuts and bolts, bits and bobs, you can weld the whole lot together as well. Material requirements and suitable material properties. Right, what I've done with my group, I just wrote a few things up here on the board. Let's make that just a little bit bigger so you can see it on the screen. So if you are on your mobile phones, you should be able to see this easy enough. Okay, so low carbon mild steel for fabrication, normally S275. You're not going to be using EM3, EN8s, EN24s, 36 and up. This is so mild steel for fabrication. This is malleable, strong, it's dense, that makes it heavy, weldable. Of course it is. Will rust, but it needs to have some paint. Okay, so oxidize it quite easy. The tubes, if you're going for some tubular assembly, you'll look at that tube which will have a welded seam. So basically that was a long strip of metal. They rolled the sides up to make a tube, and where they've joined, they've welded that seam. Ignore the bubbles that you see here. HE30 is the derivative of the aluminium alloy that you want. Again, it's malleable, okay, strong, density, it's lightweight, definitely weldable, will oxidize, also needs painting. Where steel oxidizes and goes orange, aluminium oxidizes but has a white powder on. You can color it or use a clear lacquer on there as well. Can be extruded into tubes. These are seamless, like where the steel was welded. This will be seamless. I think they might be using HE9. I can't remember. It's going off the top of my head there. S316, which is the stainless steel derivative of sheet metal. Okay, let's put it this way: we are not putting this in our sport. It does not need to be stainless steel. It is malleable, not as easy as steel and aluminium. As they say, I think it's the same. Strong, dense. It is heavy. Weldable, will not rust, mainly used in hospitals and clean applications. When it comes down to costs, if you look at the stainless steel, that's the most expensive one out of the lot. S275 is your mild steel, will be the cheapest of the lot, and obviously the HE30 will be cheap. Let's put it this way: for every one you make out of stainless steel like this, you could probably make 4 or 5 of them, maybe 6 assemblies, and painted for the cost of this one being made out of stainless steel. That's the difference. 4 or 5 times more expensive than the steel. It's going to be painted. It's only got to last 8 years. You make out of stainless steel, it's going to last for 30, 40, 50, last forever near enough at that spec there. So think about material properties. It's just one of these things that you're just bang out a list like this, and make sure you got that. Now, handwrite it if you wanted to, take a picture, stick it on your research notes and stuff like that. It's entirely up to you. But make sure whenever you do these, identify this as material properties. If you look at manufacturing, make sure you've got subheadings in your thing. So instead of you trying to read through your notes to find out what section does what, the subheading will tell you what's going on in that area there. Put it in text boxes, put flowers around the outside. I don't care how you do it, just make sure you identify which is which. That will cover material requirements and suitable material properties. So what do you think so far? I'm hoping this is making sense to you. The format, generically, it will work for all what you need for this, for your research task. Think about the product that you're after. So when he looks at the existing designs for work platforms, it'd be existing designs for whatever it is. We've had pulley systems, we've had lids for this, dunking stuff into fluids for treatment and stuff like that. It's the same thing. Think about those. Now, what you don't need to do is put three images of the same item. Okay, that's just a waste of time. You need 3 images of different items, 3 or 4, maybe 5 images. Okay, so some of you will struggle for creativity. So if you've got an image of something that is for that job, it's going to give you a good helping hand there. Reduce the margins on your Word document and make your text as small as what you can read. If you like the content I'm creating, feel free to follow. As I say, it costs you nothing. It helps me grow my channel. If you do follow from this, thank you in advance. The health and safety requirement for the product, user and the manufacturing process. Well, let's put it this way. The product, okay? Do you want to catch your hands on it? Any sharp edges? Do you want to use poisonous paints? Now, we already got rid of lead paint. You're not going to see lead paint in it ever again. Think about the user, how you made that product safer for the user to use. Okay, so obviously what I see on the top, it's a smooth flat surface. So I really wanted to make sure that was a anti-slip surface on there. At the moment there's no handrails on what you've got so far, so I will put handrails on the side there. So the products that you're seeing have got handrails or safety barriers, whatever you want to call it. A couple of them had raised edges, so your feet would not go off the edge of the workpiece and something like that. And the manufacturing process, well, someone's got to cut it. If you're using laser cutters, you have to protect their eyes, and obviously you have to extract the fumes. If you're using plasma or oxyacetylene, again, you've got to be careful of the heat. Also the fumes that come off it and something like that. If you're wet spraying or powder coat painting, you now need to think about again extraction of the fumes and catching off the paint. Now we don't want the powder going off in the atmosphere. You want to capture that, so there'll be some filters and bits and bobs that hold on to that. A manufacturing process, so CNC equipment, obviously your employers need to be trained on it. At the same time, if you're using the bending equipment, you've got to be careful that they don't catch their hands on it, so you'll have all the safety barriers. On the folding equipment, normally have a light barrier. If you break a light barrier, should stop the machine straight away. Well, someone's got to lift those plates up. Now, a 3mm plate at that sort of size, 1/2 metre by 1/2 metre, it's going to be heavy to handle. So you now have to think about manual hand, obviously PPE for the manufacturing process, eyes, breathable equipment or extraction fans. So if you're welding, there'll be extraction fans on there. Health and safety of, let's say, welding, painting, laser cutting, plasma cutting, like this is. If you're looking at the health and safety requirements of the product, we don't know what the problems are. We only hazard the guess when we looked at this. I've got to make that safer for the user. It's too big a step for you to step up on to. So I would be putting either a single step in there. Okay, no good putting one down the bottom here, because you're already there. Would you agree? You're already on the floor, so you need to step up onto this one and then onto the top there. The edge, well, there's no edge or uprights on there. I would put an edge on there to stop, so you can feel. So if you're looking into the control box above this, you can feel the edge of your work platform. Think about safety barriers. So you want some tube. You're making safety for the product. Anti-slip surface. it's painted, it gets a little bit damp or whatever like this, or a touch of oil, you're slipping off there like an ice rink. You see what I'm saying? This is all the bits and pieces that you should be discussing in your research notes. Just take it, you should be talking to yourself about that. Environmental considerations, including sustainability. Let's take a look at the manufacturing process. Right, as long as you don't poison the earth to do that. Think about the abundance of the materials that you have. You could get away by using recycled materials that be melted down to produce the new sheet that you're going to use for this, and such like that. You know, I'm going to have to leave that with you. You can put as much or as little as you have on there. Sustainability. Well, what happens if a part breaks? Well, you need to make a new one. Now, if you do buy certain bits and bobs, I'm going to apply proper swivel casters with brakes on. Okay, I want to be able to replace those quite quickly, off the shelf components and such. So maintenance of the part. If you break a bracket, can you weld it yourself? Can you touch spray it up yourself on that business? You know, the sustainability there. I'll let you choose how you want to put notes on there. Now it needs to be relevant to that product. Okay, no good talking about the other bits and pieces that are not relevant for what I've bit there. Other relevant factors that you see here, such as the application of fittings, devices, methods, mechanisms to enable ease of use and design and risk. We don't know what the problem is. We're only guessing what the problems are there. Fittings, nuts and bolts that we can use on there. Devices, there'll be mechanisms or ways of, let's say, methods or mechanisms that could be using a braking mechanism or disengaging or engaging the wheels that you have there. It might be a simple thing where the wheels are on one side. If you pick up one side at a certain height, it will engage the wheels on the floor, and away we go. You're going to have to design out the risk. You can clearly see that nylon does not have any mechanical grip on any surface. We make nylon bearings out of them. They're not fast running bearings, but we do make nylon bearings as such. But if you change the casters or add casters which have a rubber tire to it, you're going to have a lot more mechanical grip on there. Okay. Some of these casters have built-in brakes, so that would be fantastic. Now, if you have all four wheels that are got brakes on, fantastic, job done. If you use four wheels which have got their own brake to it, you can now start to see, well, actually that's not going to go anywhere. If you put one wheel with a brake, so it stops it moving from the position, just remember the other three are not got no brakes to them. It will swivel on the wheel that you have. So if you think about the person using this push, the slight push will actually swivel it on the broken wheel. So you need to make sure you have a one brake on the front, one brake on the back, or just brake all four. Nuts and bolts, think about using nylock nuts. So if there is any vibration, that's unlikely to come undone. I say you're looking at these things. What mechanisms have you seen on the images that you've done your research? Just looking at this, we have 1, 2, 3, 4, 5, 6 bullet points, as you see there. As long as you've got something for it. And okay, if you're going in there half-cocked and only doing half a job or quarter of a job, you're going into the exam room with hardly any information. You are really going to make yourself struggle. Health and safety requirements for the product. I forgot about this one. Think about the HSC, what they say about working from height. Safety barriers on work platforms. There is something on work platforms, I'm sure there is. There's got to be. They've got everything about oils, slips and trips and all that business. There must be something on work platforms. See if there's something about that. The rails have to be a certain height. If they're too low, you'll topple over it. If the gap in between, there's no good having a rail that's waist height and there's nothing underneath. You'll slip out from underneath. So think about the uprights or the kickboard, so you can feel for the edge. You could clearly see off some of the examples that I've shown you off the Google search for the images. Some had some edges where you could feel the edge. It's got to be a certain height they have to be. Obviously, too small, too short is going to be not good enough. You need to explore what you see here. Is it relevant for everything? You've got to be relevant for the product that you're looking at. It's no good doing forklift trucks. There is no forklift trucks here. No good doing Ridor on this. It's working from height. Okay, slips and trips, you're going to try and reduce the slips and trips on this. You don't want to fall off it, so you now need to put safety barriers up, as long as you call it the right one. That's the end of the video. Hopefully I've helped you out understand the process of the research task. Just remember that you've only got 2 pages of one sheet. When you open up in Word, go to layout, reduce go for narrow margins. When you use any images, don't do small images. You cannot zoom in on a piece of paper. Just make sure you have large enough images. You should be able to get 3 decent sized images across the page. Anything that you need to zoom in on, expand, crop the bit you don't want off, and then keep that as look at the way things are put together, bolted, welded, riveted. It might be that some of the mechanisms that you can't really see in the photo, so you're gonna have to dig deeper into that. So for this one, this particular one, it has wheels which have brakes on, which I've used. You've got ones with a lever. You got big ones, small ones. Don't poo-poo anything that doesn't look quite right, or it's too big for the job. You can use some elements of those, let's say, those existing products, and reduce them for your product as well. So if you're lifting, if you're looking for the health and safety bits, depending on what the product is, you need to make sure it's relevant for that. Now, don't go for the cheap shot. Health and Safety at Work Act 1974. It's an umbrella act. It has everything underneath it. So the big umbrella act, all your acts go underneath it. So there is something for slippery surfaces. There is something for working with height. It is something for chemicals. There is something for reporting accidents. You name it, they've got something for it. Okay, just make sure it's relevant for the product that's there. Please don't go and look for working on height on something that is something totally irrelevant to it. Okay, environmental considerations and sustainability. Think of the product. Okay, generically think about getting the odds and sods for environmental and sustainability. Now think about sustainability of, well, if it breaks, I need to repair it as we go from there. Can I get spare parts? Can it be repaired in-house? One of the wheels are broken on this particular product. Can I buy a new one? Of course you can. It's off the shelf. I say there's nothing special about those wheels. They just come off the shelf. There's not a lot more I can say about this. I hope you enjoyed the video. Give us a follow. There will be 5 more coming out for all individual tasks. The first couple are going to be shorter than the other ones. I think I'm going to go quite heavy over top on the last one, and away we go. Right. For my lot, if I see you out and about, say hello. That's important. If you've got any questions, put them in the comments. I will answer them for you. It's I don't get many, but if you do ask any questions, give us a shout. I'll help you as best I can. What you can't do is ask me for what the relevant exam is at that time. Just remember that. Anyway, ciao for now. See you about.